Now we will study what are the characteristics, properties or features of electromagnetic waves. Now that electromagnetic wave is as shown in the figure. It consists of the electric vector. We have taken the electric vector along the x-axis and the magnetic field vector, it is taken along the y-axis. These two are perpendicular to each other and perpendicular to the direction of propagation which is along the z-axis. Now first feature of this electromagnetic wave, now these waves contain the electric field vector and magnetic field vectors. These waves contain electric field vector and magnetic field vectors which are timely varying or oscillating. Those two fields are perpendicular to each other and also perpendicular to the direction of propagation. These two are perpendicular. They are perpendicular to each other and also perpendicular to the direction of propagation. That is the first feature. Second one, these electromagnetic waves, they do not require any material medium for their propagation. No medium is necessary. That means these electromagnetic waves even travel in free space or vacuum. They do not require any material medium for their propagation. That is the second property. Now third property, all the electromagnetic waves, all the electromagnetic waves, they travel with the same speed in air or vacuum. In vacuum, that is the speed of light. All the electromagnetic waves, irrespective of their wavelength or frequency, all the electromagnetic waves are traveling with the same speed in vacuum or free space. Now that speed is given by 3 into 10 to the power of 8, it is meter per second, that is the speed of light. And one more thing, that the speed is given by 1 upon square root of mu naught into epsilon naught. Mu naught is permeability of free space and epsilon naught is permittivity of free space. That is the third property. All are traveling with the same speed in vacuum. But if you have a medium, if you have some medium other than vacuum, then obviously the speed of all the electromagnetic waves, it depends on the two terms. One is the permeability of the medium, that is mu, and another one is permittivity of the medium, that is epsilon. In the case of a medium, the speed of the electromagnetic waves depends on the two factors. One is permeability of the medium, another one is permittivity of the medium. Therefore, the speed of the electromagnetic wave in a medium is given by 1 upon square root of mu into epsilon. Here the speed depends on these two factors. You should remember that one. That is the fourth property. Then we have a fifth property. Now these electromagnetic waves, just like waves, ordinary waves, they undergo refraction, diffraction and polarization. Now, all these electromagnetic waves, they undergo refraction. Just like a light, they undergo refraction, diffraction. All these phenomena you will study in optics branch. Diffraction, polarization. These are some phenomena related with the light that we will study in optics. All the electromagnetic radiations, they undergo refraction. diffraction, and also polarization. That's the fifth property. Now, sixth property. These electromagnetic waves, they carry energy and momentum. They carry energy and momentum, all the electromagnetic radiations. Since they carry energy, that energy is divided between the electric vector and the field vector. If it is carrying some energy of U, then half of this energy, that is half U, is divided to the electric vector, and another half of the energy is divided to the magnetic vector. That means the electric field and magnetic field, they equally carry the energy. Their sum should be equal to the total energy carried by the electromagnetic waves. And also they carry momentum. Since they are carrying momentum, they exert pressure, and that pressure we call it as radiation pressure. Since it is carrying the momentum, it exerts pressure on the surface on which it falls, and that pressure here we call it as radiation pressure. Now this momentum is given by, if U is the total energy carried by the electromagnetic wave and P is the momentum, then this momentum is given by total energy divided by the speed of the electromagnetic wave. Now this relation gives momentum and the total energy. We know that earlier the energy, electric energy is given by U is equal to half epsilon naught E RMS whole square. Now this is the electrical energy that we have studied, energy density, electrical energy density, energy per unit volume. Similarly, we have magnetic energy. Magnetic energy, this is electrical energy UE, magnetic energy UB, it is equal to B RMS square divided by 2 mu naught. This is the expression for electrical energy in the case of in an electromagnetic wave. Now this is the expression for magnetic energy which is traveling with the electromagnetic wave. Their sum represents the total energy carried by an electromagnetic wave. Since these electromagnetic waves are polarized, we have a radio having a telescopic antenna. We have a small radio, you might have observed that one. This is the radio if you have. Now it has a telescopic antenna here. Now this telescopic antenna, it responds to electrical signal of this electromagnetic wave. Therefore it should be vertical and receives the electrical part of the electromagnetic wave. If this antenna is kept horizontal, then that signal suddenly dies out and we could not receive the proper station. In order to receive a proper station in radio, we have to put that antenna in the vertical direction so that it absorbs the electrical part of the electromagnetic waves. We have some other radios that are little bit larger in size. Now inside that radio, we are having a horizontal antenna, which is a coil. We are having an horizontal antenna. Now that responds to magnetic field of the electromagnetic waves. Now this is vertical antenna, responds to electric field. Now we have an inbuilt antenna inside a larger radios. Now that inbuilt antenna is horizontal and it responds to magnetic field that is present in electromagnetic waves. And therefore this radio has to be kept according to the direction of that station. Now, if we have a station here, now this is the station which is going to radiate the signals, then this antenna has to be held normal to the direction of the station. It should be held normal to the direction of the station in order to receive the magnetic fields. If you kept the radio so that its antenna is along the direction of propagation of that one, then we can't receive the proper signal. Now, all these things will be explained on the basis of polarization. That means electromagnetic waves are polarized. That means very simple. The vibrations are restricted to a particular direction. That is the meaning of polarization. Now, these are some properties of the electromagnetic waves. And also we have one more property, intensity. The intensity of the electromagnetic wave, it is energy, total energy crossing per unit area per second. The intensity is total energy crossing per unit area per second, and it is given by epsilon naught ERMS square into C. So since the electrical energy and magnetic energy both are equal, therefore electrical energy is half of epsilon naught ERMS square plus half of epsilon naught ERMS square. If you add them, I will get epsilon naught ERMS square. Now, since intensity is the total energy absorbed per second per unit area, therefore it is given by this relation epsilon naught ERMS square into C. Epsilon naught ERMS square into C, it represents the intensity of the electromagnetic radiation. The same intensity in terms of magnetic field, it can be written as only this one is changing. B RMS square into C divided by mu naught. B RMS square into C divided by mu naught, it represents the intensity of this electromagnetic radiation. Now, these are some features of the electromagnetic radiations. Next, we study electromagnetic spectrum. An orderly arrangement of all the electromagnetic waves according to their wavelength or frequency. An orderly arrangement of all the electromagnetic waves according to their frequency or the wavelength is called as electromagnetic spectrum. Now, with the increase in frequency, first we have radio waves. Then comes microwaves. Next, IR rays or radiations. Next, visible light. According to their increasing frequency. Then ultraviolet rays or radiations. Fifth one. Sixth one, X-rays. And last one is gamma rays. Now, these electromagnetic waves which are arranged according to their increasing frequency or decreasing wavelength, and this orderly arrangement of these electromagnetic waves is called as a spectrum. Now, here in this spectrum, radio waves, they are having the lowest frequency. In terms of wavelength, they are having the highest wavelength electromagnetic waves. In terms of frequency, the goes on increases. Therefore, which radio electromagnetic wave has the highest frequency? Then gamma rays or gamma radiations have the highest frequency, or in terms of wavelength, they are having the lowest wavelength electromagnetic waves. You should remember this one. They may ask for 1 mark questions. Now here, there is no exact sharp boundary of frequency or wavelength for all these radiations. There is no exact boundary. From here to here, this is radio. From here to here, this is micro. From here to here, it is IR. There is no exact boundary. There may be an overlapping of the boundaries. There is an overlapping of the boundaries. Now we will study in detail how these electromagnetic radiations are produced and what are their uses that we will study. Now let me take the first one, radio wave. Now these waves are produced by an accelerated charged particle, oscillating or accelerated. Accelerated charged particle in a conductor or a wire. ಒಂದು ವೈರ್ ಅಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಆಕ್ಸಿಲರೇಟ್ ಆಗ್ತಾ ಇದ್ರೆ ಅಥವಾ ಆಸಿಲೇಟ್ ಆಗ್ತಾ ಇದ್ರೆ that gives out radio waves. That is the production. Where they are used? They are mainly used for radio and TV communication or broadcasting. Radio and television communication or broadcasting, in that cases we are using radio waves. The frequency of the radio waves, they range from 500 kilohertz to 1000 megahertz. The total frequency range of all the radio waves. Among them we will study one by one. First we will have AM band. Now A stands for amplitude, M stands for modulated. It is a method of modulation. AM band, amplitude modulated band, it ranges from 530 kilohertz to 10 kilohertz. If you look into that radio, ಮನೆಯಲ್ಲಿ ಒಂದು ಇರತಕ್ಕಂಥ ಒಂದು ಹಳೆದ ರೇಡಿಯೋ ಇದ್ರೆ ನೋಡ್ರಿ, in that we will have this range AM band 530 kilohertz to 1710 kilohertz band. That is AM band. Next we have shortwave band. Shortwave band, it extends from 1710 kilohertz to up to 54 megahertz range. They are called as short wave bands. We can see that one. In the upper region we are having AM band, and the next region we are having short wave band, SW1, SW2, SW3, like that we are having this range of bands. Now these signals, they are reflected from the ionosphere, therefore they are short wave bands. And third one we have FM band. You can observe this one, FM band. Now this FM band, frequency modulated band. So here the frequency is modulated band. It has a frequency range of 88 megahertz to 108 megahertz. Now what is the difference between the AM band and the FM band? AM band having a longer range, but it has a distortion. But FM band has a shorter range, but voice quality is very clear. Then we have TV band. Now it has the frequency range of 54 megahertz to 890 megahertz. All the television bands, they are having the frequency range from here 54 megahertz to 890 megahertz. And lastly we will be having cellular phones. That is mobile phones. They are transmitting the signal in the ultra high frequency, UHF, ultra high frequency range. Now these are regarding the radio waves. That is the first one. Second one, microwaves. Now these are the electromagnetic radiations having a frequency little bit higher than the radio waves. In terms of wavelength, the radiations whose wavelength is lesser than the radio waves. Therefore, they are called as microwaves. How they are produced? They are produced by a special type of vacuum tubes. Special type of vacuum tubes called klystron. Klystrons, magnetrons, and one more, gun diode. By these three devices, these microwaves are produced. Since they are having a shorter wavelength, they are mainly used for radar system. That is RA, radio detection and ranging. That is radar system. Radio detection and ranging. That radar, in that radar system, we are using these microwaves. Now this system is used for the navigation of aircrafts. Aircraft ಅಲ್ಲಿ air traffic control system ಅಲ್ಲಿ ಈ radar system ಅನ್ನು use ಮಾಡ್ತಾರೆ to navigate the aeroplanes, aircrafts. And also this radar gun is used to find the speed of a ball in sports. For example, in a cricket, if a bowler is bowling, at what speed he is bowling the ball, that can be detected by using this radar gun. In the case of a tennis, lawn tennis, if a sports person serves the ball, at what speed that ball is served, that can be detected by using this radar gun. And in case of traffic controller, police, he is going to detect, identify at what speed the vehicle is approaching or it is passing. So everything is using this microwaves in radar guns. And more important is, these signals or these waves are used in microwave oven. So microwave ovens ಅಲ್ಲಿ ಈ ಸಿಸ್ಟಮ್ ಈ waves ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. Now these radiations, they are going to oscillate the water molecules which are present in the food that is to be cooked. Now they will absorb this microwave energy and they heat up the food. In microwave ovens also, we are using these microwaves. Now this is the second radiation. The third one, IR, infrared waves. Now these are produced by any hot body or a molecule. They are produced by any hot body or molecule. Since they are having more heat, they are also called as heat waves. Any object which receives these IR waves, it gets heat up and heats up the surrounding, and hence they are also called as heat waves. Now what are the uses? IR lamps are used for physical therapy. IR lamps are used for physical therapy. That is the first use. Now secondly, these IR waves keep Earth's atmosphere. Warmer. They keep Earth's atmosphere warmer by the effect called greenhouse effect. By the effect called greenhouse effect. The another uses of these IR radiations are they are used in Earth satellites. For military purposes and for growth of crops in agricultural land. For that purposes, in these Earth satellites, we are using IR radiations. And one more use is they are used in remote switches. Remote switches which are used in all electronic devices, that in TV remote, VCR remote, all other remote switches, we are using this IR waves. That is the third one. Now this frequency is little bit higher than microwaves, and this frequency is overlapping with the lower frequency range of the visible light. That lower frequency of the visible light is the red light. Therefore, it is called as infrared. Since it is overlapping the frequency of the red light, therefore it is called as, these are called as infrared waves. Now fourth one is visible light. This is the only small part of the electromagnetic spectrum which is visible to the naked eye. Now its frequency ranges from 4 into 10 to the power of 14 hertz to 7 into 10 to the power of 14 hertz. That is the frequency range of the visible light. Or in terms of wavelength, we are having 700 nanometer to 400 nanometer. In terms of wavelength, we are having. Now 700 around it corresponds to red, and this 400 corresponds to the violet. Now because of this visible light, we are able to see the whole world. We are able to see the objects because that each and every object is going to reflect the visible light. That is the fourth one. Next we have the fifth one, that is ultraviolet rays or radiation, ultraviolet. Now here, since we are having violet in the visible spectrum, the electromagnetic radiations which are little bit higher frequency than the visible light are called ultraviolet waves. They are produced by a special lamps. They are also produced by some special lamps. Their frequency range is little bit higher than the visible light. Since they are having a little bit higher energy, they are harmful to the living things. But luckily, even though sun is sending the ultraviolet radiations, Earth's atmosphere has an ozone layer which is going to absorb almost all the ultraviolet radiations coming from the sun, and hence all the living things on the earth are safe by this ozone layer. Now this ultraviolet radiation, when it falls on the skin, it increases the melanin. If it falls on the skin, it increases the melanin, which causes tanning of skin. Now that causes tanning of skin. Now the uses of the ultraviolet radiations are, they are used, ultraviolet lamps are used to kill the insects, or they are also used in mosquito repellents. Ultraviolet radiations are used in mosquito repellents. They are used to kill the insects. And in water purifier, we are using the ultraviolet lamp. Ultraviolet lamps are used to kill the germs which are present in the water. That water purification process uses this ultraviolet radiation. And the other uses, they are used in the eye surgery technique, LASIK, eye surgery technique, LASIK. In that case, they are using the ultraviolet radiations. While welding, persons are wearing the glass mask to avoid the ultraviolet rays entering into the eye. Now, these are some application uses of this ultraviolet radiations. Now, next one. Now, here from third to fifth one. Now, IR waves are produced by any hot body at lower temperature. If slowly increase the temperature, you will get the visible light. If you further increase the temperature of the same hot body, then you are getting ultraviolet rays. For example, if you take an iron nail, heat it at lower temperatures, it gives out IR waves. If you further heat it, we will get visible light. That iron becomes red. If you further goes on increasing it temperature, it turns out to be white in color. If you further increase, it turns out to be little bit violet. Then it's going to emit ultraviolet rays. You should remember that. Now, sixth one is X-rays. Now, these are produced. How they are produced? They are produced by bombarding a metal with the electrons. If we have a material, it is bombarded by an electrons. The secondary electrons are emitted from that material, and those secondary electrons are called as X-rays. It was discovered by Rontgen. And these rays, they are having little bit higher energy or higher frequency compared to the ultraviolet rays. Therefore, since they are having higher energy and higher frequency, they have more penetration power. X-rays are having more penetration power. Then what are the uses of this one? It is used in a medical field for the diagnosis of the foreign bodies which are entered a human being. ನಮ್ಮ ದೇಹದಲ್ಲಿರ್ತಕ್ಕಂತಹ ಯಾವ್ದಾದ್ರು ಫಾರಿನ್ ಬಾಡಿ ಎಂಟ್ರಿ ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, ಒಂದು ಕಾಯಿನ್ ಅನ್ನು ನುಂಗಿದ್ರಾಗಿರ್ಬೋದು, ಅಥವಾ ಬೇರೆ ಏನಾದ್ರು ಮುಳ್ಳು ಚುಚ್ಚಿರೋದಂಥದ್ದು, ಅಥವಾ ಬೇರೆ ಏನಾದ್ರು ನೇಲ್ಸ್ ಒಳಗಡೆ ಹೋಗಿದ್ದಾಗಿದ್ರೆ ಅದನ್ನ ಡಿಟೆಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಎಕ್ಸ್ರೇ ಟೆಕ್ನಾಲಜಿಯನ್ನ ಮೆಡಿಸಿನ್ಸ್ ಅಲ್ಲಿ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ ಟು ಫೈಂಡ್ ದ ಫಾರಿನ್ ಬಾಡೀಸ್ inside us, and it is going to identify, is there any cracks in our bones, bone crack. That can be detected by using this X-ray technology. And they are also used in identifying flaws or any defaults in machinery parts. If there is any machinery parts defaulted, that can be detected by using X-ray technology. And they are also used for the treatment of certain cancer cells. Cancer cells treatment allu sah X-rays anna use ಮಾಡ್ತಾರೆ. Since they are having high penetration power, if you expose more to the X-rays, it will be harmful to the human being. That you should remember. And the last one, gamma rays. Now, these are the electromagnetic waves having the highest frequency. In terms of frequency, highest frequency. In terms of wavelength, the lowest wavelength electromagnetic rays, lowest. Lowest wavelength electromagnetic waves are highest frequency electromagnetic waves. How they are produced? They are produced in nuclear reactions. nuclear fission process or fusion process like that. In those nuclear reactions, these gamma rays are emitted. And in a radionuclide, or radioactivity, in that process also we are obtaining these gamma rays. Since they are having higher energy compared to the X-rays, they are having more penetrating power. The electromagnetic radiation having the highest penetrating power are gamma rays. Since they are having highest energy penetrating power, the ionization power becomes lesser. They are vice versa. If the penetrating power is more, the ionization power is less. If the penetrating power is less, then the ionization power is becomes more and more. Now, these gamma rays are also used for the treatment of some cancer treatment. They are also used in some cancer treatments to kill the cancer cells. But once again, since they are having the highest energy, more exposure to the gamma rays will be harmful to the human being. Now that is the electromagnetic spectrum. Lastly, we will study this table showing the types of the electromagnetic waves, their wavelength range, the production, and the detection column. Okay, take the first one, radio waves. They are having the wavelength range greater than 0.1 meter. 0.1 meter. How they are produced? A rapid acceleration and deceleration. That is the oscillation of the charges. That is electrons in an aerial. By that one they are produced. How they are detected? They are detected by the receiver's aerial, that is antenna. Antenna will detect those radio waves. Second one, microwaves. Their wavelength range. Wavelength range is 0.1 meter to 1 millimeter. 0.1 meter to 1 millimeter decreasing wavelength. They are produced by using a special type of valves, vacuum valves. They are klystron, magnetron valves, or gun diodes. How they are detected? A point contact diodes. A point contact diodes can detect these microwaves. Third one is infrared. Their wavelength range is 1 millimeter to 700 nanometer. This is millimeter, this is nanometer, 700 nanometer, which comes around the red region of the visible spectrum. Now, how they are produced? Any hot body, that is vibration of the atoms or molecules in any hot body, which gives out these infrared radiations. How they are detected? By using some devices called thermopiles. They can detect IR radiations, bolometer, IR photographic films. Now these IR radiations can also be used in binoculars, IR binoculars, infrared binoculars. By these binoculars we can view the objects even in total darkness. Okay, they are used in military. They are used in military purposes. The fourth one comes visible light. It is the only spectrum which we can see with the naked eye. It has a wavelength range 700 nanometer to 400 nanometer. 700 corresponds to red light and 400 corresponds to the violet light. So how they are produced? Whenever electron jumps from a higher energy level to the lower energy level. Now here electrons which are in the outermost orbit, they are jumping from higher energy level to the lower energy level, then the light is emitted. It is in the visible spectrum. Now how can you detect the visible light? By the normal human eye or any animal eye, photocells and photographic film. A photographic film, when it is exposed to the light, it gets affected. Next one, fourth one is ultraviolet rays. It has the wavelength range 400 nanometer to 1 nanometer. Wavelength is decreasing. Okay, 400 nanometer to 1 nanometer. How they are emitted? Now they are emitted in the similar way of visible light. But in the case of visible light, outer shell electrons are jumped from higher energy level to the lower energy level. In the case of ultraviolet light, the inner cell electrons are jumping from higher energy level to the lower energy level. By that one, they are emitting the ultraviolet radiations. How they are detected? Once again, they are detected by using photocells and photographic films. And the sixth one, that is X-rays. Now they are having the wavelength range of 1 nanometer to 10 to the power of minus 3 nanometer. Nanometer, it is decreasing. How they are produced? They are produced in an X-ray tube, or the inner cell electrons are going to emitted once again here. Whenever a material, a target is bombarded with an electron, the secondary electrons are emitted. They are emitted from the inner cell. They are emitted from the inner cell of the atom, and hence they are having higher energy. How they are detected? By using a photographic film, Geiger tube, or ionization chamber. And the last one is gamma rays. Now they have the frequency, they have the wavelength range lesser than 10 to the power of minus 3 nanometer. They have lesser than 10 to the power of minus 3 nanometer. How they are produced? They are produced in radioactive decay process of the nucleus. Radio nuclear reactions. In the nuclear reactions, we are finding these waves. How they are detected? They are detected in the same fashion as that of the X-rays, that is photographic film, Geiger tube, or ionization chamber. Now that completes this very small chapter, electromagnetic waves. We will work out simple problems regarding this chapter. A plane electromagnetic wave of frequency 25 megahertz travels in free space along the x direction. The wave is traveling along the x direction. At a particular point in space and time, the electric field E is given by 6.3 J vector. That is along, since it is J, the electric field is along the Y direction, volt per meter. What is the magnetic field at that point? Very simple problem. Now solution. Now here, if you write a simple diagram, if I take this is the x-axis, now that indicates the direction of propagation. Now this is the electric field vector, that is along the y-axis, since they have given j cap. Obviously, where is the direction of the magnetic field? Obviously, the magnetic field is along the z-axis. It should be along the z-axis. Okay. Now the magnitude of the electric field is 6.3 volt per meter. Now speed of the electromagnetic wave, we know it is 3 into 10 to the power of 8 meter per second. We have to calculate magnitude of the magnetic field. We have a simple relation between the velocity that we have studied in the fourth chapter, that is velocity selector. Based on that one, the velocity of the electromagnetic wave, speed of the electromagnetic wave is given by the electric field, magnitude of the electric field to the magnitude of the magnetic field ratio. It is the ratio of electric field to the magnetic field. So since we are in need of this one, magnetic field, therefore it is equal to electric field divided by the speed. Now electric field is given, it is 6.3 divided by speed is 3 into 10 to the power of 8. Now if you simplify, we will get 2.1 into 10 to the power of minus 8 Tesla. That is the magnetic field. Now here given the electromagnetic wave is propagating along the x-axis and the electric field is along the y-axis. Obviously, by the definition of electromagnetic waves, the electric field vector and the magnetic field vector should be mutually perpendicular to each other and also perpendicular to the direction of propagation. Therefore, the magnetic field vector is along z-axis, which has a unit vector k cap. So therefore, the magnetic field vector is given by 2.1 into 10 to the power of minus 8 K cap Tesla. K cap Tesla. And one more thing you should remember, the electric field vector, cross product of magnetic field vector, it gives the direction of propagation. Electric field vector, cross product of magnetic field vector gives the direction of propagation. Now this simple thing you should remember. Next problem. Light with an energy flux of 18 watt per centimeter square falls on a non-reflecting surface at normal incidence. If the surface has an area of 20 centimeter square, find the average force exerted on the surface during a 30-minute time span. Okay. Now we have a surface on which the electric flux, the energy flux is falling. Its area is given and we have to work out what is the force exerted on the surface. Now given, what are the given things here? Electric flux is given, energy flux is given, that is light flux is given, that is 18 watt per centimeter square. Since it is given per centimeter square, we convert it into meter square, therefore it is 10 raised to minus 2 whole square. Therefore it becomes 18 into 10 to the power of plus 4 watt per meter square. 18 into 10 to the power of plus 4 watt per meter square. It falls on a surface which is area of the surface. It is area is 20 centimeter square is given. If I convert it into meter, 20 into 10 to the power of minus 2 whole square, or I will get 20 into 10 raised to minus 4 meter square. And time is given 30 minutes. Time is 30 minutes. I will convert it into seconds. That is 1800 seconds. Now first we have to calculate what is the total energy falling on that surface. Therefore total energy falling on that surface U is equal to, it is the energy flux multiplied by area multiplied by the time. That gives the total energy. Now flux is 18 into 10 to the power of 4 and area is 20 into 10 raised to minus 4 into 1800. Therefore, if you 10 raised to plus 4 and minus 4 get cancels. Now if you simplify this one, 18 into 20 into 1800. I am getting 648,000 joules of energy we are getting, or this one is equal to 6.48 into 10 to the power of 5 joules. Next, we have to calculate momentum. We have the relation. If you know the total energy, then we can calculate the momentum by simple relation U by C. Momentum P is equal to U by C. Now U is 6.48 into 10 to the power of 5 divided by C, the speed of light, 3 into 10 to the power of 8. Now if we simplify this one, 6.48 divided by 3 is equal to 2.16 into 10 to the power of minus 3. 10 to the power of minus 3 kg meter per second. Kg meter per second. This is the momentum. Now we have to calculate what is the force exerted. The average force exerted on the surface, force is equal to It is the rate of change of momentum. Therefore, it is P by T. Now, P is 2.16 into 10 to the power of minus 3. Total time 1800. Or I will write it as 2.16 into 10 raised to minus 3 divided by 1.8 into 10 raised to plus 3. Okay. So 2.16 divided by 1.8, that gives is equal to, therefore force is equal to 1.2 into 10 raised to minus 6 Newton. 1.2 into 10 to the power of minus 6 Newton. Now this amount of force is exerted on that surface. It is very small force.